We're going to provide you with a quick demonstration of SolarFlare's SolarSecure solution, which includes two components, Domain Fortress and ServerLock. SolarSecure was designed for SolarFlare's NICs with ServerLock. It leverages key security features designed into the NIC silicon. There are two software components that make up SolarSecure. We have Domain Fortress, which is a centralized controller that manages all the SolarFlare ServerLock NICs within an infrastructure, and we have ServerLock. To utilize SolarSecure, one needs to execute a one-time binding process between the local server, the adapter, and the Domain Fortress. This binding process executes a cryptographic key exchange over a TLS connection between the ServerLock NIC and the Domain Fortress. Once a NIC is bound, ServerLock on the NIC is engaged, and it prevents changes in the security policy from a local user in the event that the server becomes compromised.
Here we have an example Thomson Reuters enterprise platform. We have the market data network in red, the TREP backbone in blue, and the trading platform in green. Market data comes in at the top, and trades are executed at the bottom. We're going to use SolarSecure to protect all of its servers. In doing so, we're going to show you how it only takes a few minutes to set up and run a security policy for hundreds of firewalls executing in the ServerLock NICs. We'll show you how Domain Fortress learns from the network flows and how ServerLock enforces in silicon application segmentation. By the end of this video, you'll know how to set up SolarSecure to test firewall policies, identify security risks, and stop attacks.
In this image, you can see on the bottom right that a malicious application has somehow found its way onto the trading platform TP100 system. The malicious application is going to attempt to access the system ADS30 on the backbone network.
Here we have the monitor page of Domain Fortress, and it has learned about all the hosts and all the network flows between them. Learning mode is critical to how Domain Fortress works. Once an adapter is bound to the Domain Fortress, it begins reporting to it the network flows into and out of the ServerLock adapter. Domain Fortress then displays these network flows. Flows that don't have a policy are drawn in red. ServerLock is now waiting for firewall rules to execute directly in the NIC silicon.
Moving forward, we'll use the following terms to describe these server firewall rules. A role is a template that describes specific firewall rules, like allowing DHCP or DNS. A policy is a collection of roles which define all the firewall rules for a particular type of server, like a web server or a trading platform. If we click on the details dropdown.
On the right, we now see the definitions for our infrastructure domain. There are 210 hosts, or unique IP addresses, on 180 adapters.
We'll use filter view to just see the trading platform machines. We know that the 100 subnet contains our trading platform hosts. We then execute that filter.
We can now see the 100 hosts that make up the trading platform network. So we'll select the single host, trading platform TP50, and click on that to select it. Clicking on that host again displays the drop-down menu. We now select all hosts and group them to make creating policies for a large volume of similar systems extremely easy. All hosts are now selected. Then click Make Group on the right. We've now labeled the group Trading Platform.
We've now backed out to the All Hosts view. We can now see those hosts that are a part of the trading platform group and those that are not. We'll now take a shortcut and assign all the other hosts to more appropriate groups by function. Now we can see that most of the hosts are members of groups. Now we'll click Expand Bottom on the bottom right. Here we can see a much tighter view of things with all the groups collapsed. ADH, ADS, market data, and trading platform. Services hosts at this point have not yet been placed in a group. Now if we click on the trading platform group.
In the details section on the right, we can see all the flows made by the trading platform systems, and they are grouped by service. Given the large number of connections, the screen here is scrollable, but was not captured. If we now click on roles on the left, here we can see some of the default roles provided with Domain Fortress. A role is the lowest level definition for creating a security control. It is also possible for one role to contain other roles. We can see here what comes with the default TCP client. By clicking on the DNS client, we see the default DNS client role, which also includes the TCP client and UDP client roles. Here we can define a new role and add a description along with various parameters and embed other existing roles.
So now we've created a trading platform core services role. We've now included several other roles in the trading platform role: ARP, DHCP client, DNS client, and NFS client. We're now going to modify the parameters of the DHCP client. Here, we're adding a specific server to the DHCP client. By doing this, we're restricting this role by defining which DHCP servers it can talk with. We've now filled out the remaining parameters for each of these roles. Note that wildcards are in the default, but these could be specific values, or you could just leave the wildcard values. In this case, they are specific. Now clicking back to the monitor. Now we'll select all the checkboxes on the left side of all the hosts. We then click See Policies for these hosts. We now have several default roles selected, but those are already very specifically defined in the trading platform role, so we want to uncheck DHCP, DNS, and NFS.
We can now click Create Policy. We then need to assign the policy to the trading platform systems, so click Assign Policy. So we've successfully assigned the trading platform policy. That contains the trading platform core services roles to the trading platform group. Notice now that all the links from the trading platform group to the service systems are now in green, while the undefined network flows going to the ADS and external networks are still highlighted in red. We can expand traffic exceptions.
We can now see all the remaining exception flows from the trading platform. We can then review and select all of those. With all those selected, we then click Create External. Note, we are doing this to make it easier to view and reference the roles, but it is not essential.
We can then treat the object separately or as a single object and assign these links the name Trading Desk. We're going to create several other external links defining how the exchanges are accessed for trading. We can now see that there are 3 different external types of connections that are grouped as external connections. Note, we still don't have a policy to define these, so the links are still red. We now click back to roles on the left.
We're now going to click Create to create a new role. So we're going to create the Trading Platform Internal Access role, which defines everything these servers should be permitted to do. Eventually, we'll include the following roles in a policy that may then be enforced so that only traffic for permitted flows will be allowed to enter and leave the Trading Platform servers. Note these roles and eventually policies will be loaded directly into the ServerLock NIC cards where they will be executed and enforced.
We'll now add the trading desks to the domain object parameter. Now we click back to monitor. We then collapse traffic, scroll down, and expand policy. We then click Add to add the trading platform policy. We then can check the trading platform internal access.
And add both roles, Trading Platform Core Service and Trading Platform Internal Access. We've now successfully updated the trading platform policy to include the trading desks, the link to which is now green. We'll now go back to roles and click Create. This will enable us to craft the Trading Platform Exchange Access role. We've now changed the parameters to include the 2 external exchanges supported. We'll then click Create again.
Here we'll create a TREP ADS TCP client. Place the appropriate group name in this role, then return to monitor. Now we click Add. At the bottom we see the user-created roles again and select. We then check the remaining few user-defined roles. Then click Add Roles to the Trading Platform policy.
We've now successfully completed defining our policy for all the legitimate network flows existing on the trading platform servers, as well as flows are now colored green. Note at this point we're still in trial mode, so alerts won't be generated for things outside of this existing policy.
So we can now shift to monitor mode, which still will not actually block any traffic, just validating that traffic aligns with predefined security policies. Anything that doesn't align will generate an alert. It should be noted now that one alert has popped up, so we click on the alert screen. We notice now that there is a flow exception for the NTP service. We missed this during the initial setup, so we'll click Add to add that to the existing policy.
We can then check NTP under Core Services and add it this way. Then click Add to Role. We need to add a value for the NTP server. Now let's go back to Monitor by clicking on the Monitor tab. Notice everything is green and working out great. We've now completed the setup and can leave SolarSecure to monitor the network and warn us if any issues occur. After some time, we now have another alert. Also, we can see that a flow from the trading platform to the ADS has turned red. So we click the Alerts tab.
At the bottom of the alerts list, we can still see the NTP alert, but that has been resolved. Above that is a new alert for an SSH connection, the details of which are on the right. We will now click Filter by this entry on the top right to see more. We can see that multiple SSH connections have been attempted. This looks suspicious. No, we're still in monitor mode, so that SSH connection is still permitted. It's just flagged as an exception to our defined policies. At this point, we want to block the traffic, so we will click Monitor and flip the system into Enforce mode.
Now in enforce mode, you can see that the solid red line representing the SSH connection is now a dotted red line, meaning that while the malicious app may want to make an SSH connection, it is being firewalled off by the NIC card on the host from which it is originating. If we created policies on the ADS servers, then they too would also be capable of blocking errant SSH connections.
So here we've shown how to set up SolarSecure. All the ServerLock enabled NICs have reported in all of their network flows. We've turned those flows into roles and then combined those roles into a more comprehensive application-specific policy. And we've shown how to test the policy, identify security risk, and block an attack by moving through trial, monitor, and enforce modes.
Thank you for your time, and if you have any additional questions, please don't hesitate to email info@solarflare.com.